Hello. In this work here, we're trying to make the end-to-end speech models run much faster on device by making the decoder parts of them much smaller so that they can fit in memory for edge accelerators. We focus on the RNN transducer model, and the joint network and the prediction network, we have a design for them such that put together, they have fewer than 2 million parameters. For the prediction network, in this design here, all it does is it takes these word piece tokens and it embeds them with a shared embedding matrix, and then it's just does a weighted averaging operation. That's all it does basically, and the weights just are computed out of an interaction with so-called position vectors. There's one constant random position vector for each position in the history of these non-blank tokens. And so the embedding vector needs to learn to adapt to these position vectors and learn to be emphasized or de-emphasized in the given positions. And there are no cross-position connections here, so this is easily parallelizable. This is also just one head of our prediction network. And so we actually have 4 such heads in our multi-headed design, and we average their outputs as well. In order to make the RNN-T decoder overall also much smaller, we also have a weight sharing technique here. So the output layer in the joint network and the input embedding matrix can share most of their weights if DE and DH, these hidden dimensions, are the same. So for all non-blank tokens, the weights can be shared there. And this is also very common in language modeling, actually, and we've discovered that it works well for RNN-T here. And so for a given number of parameters in the decoder, you get better word error rate if you do this weight tying versus if you don't do it. And so we compare here with the baseline, our overall design compared to the baseline, which usually has an LSTM in the prediction network and no weight tying. You see here like around 90% reduction in size and comparable word error rate. But also if you do additional minimum base risk training steps, you actually match the word error rate of the baseline. And of course, the model runs much faster and uses much less energy. And so inference will become much faster with this if it fits in memory. And you can use this to, for example, have more complex beam search on device, or maybe if you want to have one decoder per language, that's also something you can use this for.